Let's talk about Liskov Substitution Principle using Golang today. So what is this actually? So this Liskov Substitution Principle is one of the solid principles in object-oriented programming. This is actually like inheritance and subtyping. Instead, that object of the subclass should be replaceable with object of its subclass without affecting the correctness of the program. Basically what it says is in object oriented way, there is a base class. You have derived a couple of classes out of which, because of the derived classes, it should not affect the base class. This is the principle basically. But in Golang, how we can achieve this, because we don't have any classes or something here, right? So yeah, we can achieve this using interfaces and type embedding. We can see this hands on in some time. Key points of Liskov substitution principle are: subtypes should be substitutable for their base types, right? This is what I told in object oriented way. Base class should be, or derived class should be, substitutable with their base classes. Here in Golang perspective, yes, in the types or structs. Okay, object of derived class should behave as the object of the base class without affecting the functionality expected from the base class. This we'll understand very clearly with the hands-on coding. And behavior compatibility. Subtypes should honor the contracts defined by their subtypes. This ensures that object of that subtype can be used interchangeably with object of the supertype. Same thing again. So there won't be no unexpected behavior. Subtypes should not introduce behavior that is unexpected or violates the assumptions made by code relying on the supertype. They should extend behavior without altering the base behavior, right? Let us see how we can implement this. In Go, interfaces play a crucial role in this particular Liskov substitution principle. Interfaces as contracts. Define interface that specify the expected behavior of types. Subtypes adhering to interfaces, ensuring that types of satisfying an interface can be substituted for the interface without changing the expected behavior. Type embedding for composition. Use type embedding to create new types that inherit behavior from other types while adding or modifying the specific functionality. Okay. So this is about Liskov substitution principle. Again, I will repeat. Simple, which is whatever the base class you have defined, that should be replaceable for any subclass whatever you do. it, there should not be any violation or deviation from the base class behavior or functionality whatever you define at once. Derived class should follow the, and derived classes should replaceable or substitutable with the base class functionality. That's it. Okay, let's come back to the hands-on coding now. Yeah, previously we saw like no, a single responsible principle and open close principle. Today we will talk about Liskov substitution principle with hands-on. Okay, I will create LSP, Liskov substitution principle. Initially, I will try to write the main.go only. Later, we will try to refactor the code. Okay, package main. So basically, what I'm trying to do here is I will take one base class of shape and we'll try to derive the other shape classes, meaning other shapes like a rectangle or circle or something, and then we will try to understand like how we are trying to achieve the Liskov substitution principle. Okay, so for this what I will do is I will try to write one small interface, that is actually shape interface, which actually represents the contract for shapes. Okay, contracts for shapes, because any shape you can derive from this actually. That is what actually we are shape and interface. We will try to just calculate the area of the shapes, which is just a which this interface just have a one method called area. Okay, that's it. So now what we will do is we'll try to see we'll try to override this shape for the rectangle. So what we can do is we can try to create rectangle. This represent a rectangle shape. Okay, so what we will do here, a type of type rectangle which will be struct. Basically when you want to calculate rectangle area, we need height and width and height, right? So what I will do, I will try to create width of float 32, and one more thing we need is height, which is also like a float 32, that's float 64. So we have now two things. One is rectangle. We are trying to uh, implement the interface shape here, right? So for that, what we need to do is we'll try to func, which has just one method called area, right? And it just returns the float 64. So when you want to the area of rectangle is r into width into r dot height. That's it. So now we already calculating the area of the rectangle here. At area of rectangle, right? Okay. So now we are good and we are able to replace rectangle with the shape whatever we have defined actually, right? Similarly, what I will try to do is I will try to create a float. I will try to create uh, basically one more shape which is circle. Okay, circle the uh, represent a circle shape. Okay, so what we will do is we'll also try to create a struct of circle struct. Basically this is not required two parameters like rectangle has width and height, but here what we can have is we just can have the rectangle sorry circle radius. That is enough for us. So area of the circle will be pi r square, right? So we'll see that how we can get the math thing here, and then we'll see. Okay, radius of type float 64. Again, why this is showing some error? Okay, okay, cool. So now what we will do is we'll try to implement the function uh, to calculate the uh, for this circle. Okay. So what we'll do here is we can write the func of circle area float 64. We'll try to return here math.py into c dot pi r square, right? Radius. Okay. So simple actually. That's it. That's it basically. So what we will do is we will try to write one helper function print area. Here, if you observe actually we are just trying to replace uh, shape. Okay. This just prints the whatever we want. Empty dot println s dot area. Okay. I will explain to you like how we can achieve the replacement actually without altering anything actually. Okay. We will use this function. Let me write the main function now. Okay. So here let us create a rectangle. Okay. Rectangle we can oops try to write width of for example 5 comma height is 3, right? We're expecting okay. Okay, let us see now. I will try to print this one area of rect. Sorry. See, this is actually rectangle, right? But here where we have the shape, we are easily able to replace it actually. Let us run this and see, and try to understand more clearly. LSP, here, go run main.go. See that 5 3 are like 15, right? We are able to get that. Here you need to understand like we are not able to alter anything in the print area function, which is actually taking the shape parameter, right? That means we are able to replace this rectangle with this base class or base interface, whatever we created, without altering anything. Let us try to create a circle of probably radius. We can give this 4. Oh, sorry. Radius 4. Okay. Uh, we'll try to print again this radius circle. Go run. See, this is actually without altering the even circle also. It is able to replace and it is able to get whatever result we want. This is that actually the definition of Liskov substitution principle says that the base class should be replaceable with the derived class without altering anything in the base class. Still, you can go ahead and write any other shapes like a triangle, anything basically. Okay. So same thing will be same way actually we can achieve the Liskov substitution principle. Now let us make the things refactoring, because this is also one of the key thing, the making the code is more readable and refactoring. Okay. What I will do, I will try to shape.go package main. Okay, and what else we can take? We can take rectangle outside, and we can triangle dot go package Just trying to replace. After that, what we can do is we can let's keep this one here only. I will try to create one more file for circle.go. This is the way you need to make the code more readable, also more like a uh, refactoring the code in a different way so that things will be very easy. Okay, so I think that's it. I think let it be this print function here only. This also we can move to somewhere like utils or something like that. We can write. I can let us write that also. Utils dot go and package main. Just try to read this one. Let me see in main function what and all there now. That's it. Okay. So main function is very simple now, and I refactored everything. Suppose you want to add one more function, one more structure to make it the Liskov substitution principle for triangle. You can do that as a you can take it as a homework kind of thing, and you can work on that. Now let us build it. If you see there is no any executable here, let us try to run. Go build. There is a main here lsp.exe is there. Let us run that lsp.exe. Yes, you got it right. So this is the basically the everything about lsp. Thank you.